So today we're going to be working on solving systems of equations by substitution. This is going to be an alternative method to solving by graphing. You'll find that this can be a much more efficient method. It's used a lot of times in graphs where the solution will not graph easily. For example, if you take a look at this case, these lines are very close together. It is very hard to tell where they are going to cross each other. They could cross each other right here, or they could cross each other right here, or right here. They could also be crossing at decimals. They could be crossing at fractions. And because of that, that would make it extremely hard to find by graphing. It would be extremely hard to estimate a fraction or estimate a decimal by a graph. We use them when they're nice whole numbers, like 1, 3, negative 2, 7. But when they are something that's not so nice, a lot of times substitution is going to be a much more efficient way to solve that system of equations. It also helps when the graph would be really big. We'll see some numbers like that, and you don't want to have to graph something that has like a 30 or a 40 in it. That gets really large. So this is going to be our first system that we solve by substitution. And we've done substitution a lot in here before. We've evaluated problems when a variable is equal to a number. We're going to do the same now, but we're going to do it in a system. So what we're going to be looking for is a variable that is completely isolated and by itself. It's going to be, in this case, y equals. This is in slope-intercept form. It says y equals 3x. So we have y equals to something. So we're going to put a box around what it's equal to. We're going to use this to substitute in where the y is in the other equation. It has to go in the other equation, not in this one. That won't work. It has to go in the other equation from the one we're working on. So here is the y in the other equation. So we are going to substitute in our value for y in that spot. Let's show you what that looks like. X plus, now instead of writing y, that y is going to go away, and we're going to replace it with what's in our box. So it's going to be 3x equals negative 32. Now, x plus 3x is going to give us a total of 4x. Remember, there's always a 1 in front of here, equals negative 32. We're going to divide both sides by 4, and x equals negative 8. When we're looking for an answer to a system of equations, remember, we're looking for where these two lines cross each other. It's a point on the graph most of the time. There are always the exceptions, the special cases, but most of the time it is going to be a point on the graph. So that means an ordered pair, which means parentheses and a comma. Since this is the x, remember ordered pairs go in the order x and y. So this first one is going to be negative 8. To find the second one, you always do the same thing. Once you have solved for one variable, you're going to take whatever that answer is and you're going to plug it back into the box. It's always back into the box, guys. Always. Plug it back in the box once you get your first answer. So that's going to be y equals 3. And wherever the x is, we're going to plug in a negative 8. So it's going to be y equals 3 times negative 8, which makes it y equals negative 24. And again, that one might be a very large graph, take up a huge part of your paper, and we just solved it without having to do any of the graphing. Much faster than graphing a problem, and a lot easier than graphing a graph that goes down to negative 24. Okay, so remember, that means that this is going to be two lines that intersect. So these would be consistent with each other, but independent because they only share one common point. Okay, here we go. The next one, we have a situation where we don't have one already solved to where it says x equals something or y equals something. But I will say that when you're trying to find something to solve for, you need to look for the variables that don't have a coefficient other than 1 in front of them, like x and y. You don't want to look right here at the 5x or the 3y because you could create fractions. And unless you have to, there's no need to create fractions. So I'm going to take this equation that has the x and the y by itself down here and rewrite it. X plus y equals 60. I'm going to solve for one of those two variables. It does not make any difference which one you solve for at all. I'm going to solve for x just to show you, I think the last time we used y, so I'm going to solve for x this time. So I'm going to minus y, that's going to make it x equals, we're going to put the variable term in front, so it's going to be the opposite of y, and then because the 60 is positive, it's going to be plus 60. We now have what x is equal to, so we're going to put our box around it. Notice I only put it around this, I don't put it around the x, it's just around what x is equal to. I am now going to plug that x in to the x in my other equation. It has to go in the x in the other equation. So it's going to plug in right there. It's going to be 5 parentheses. Guys, the x here goes away. That's the whole idea, is to get one of your variables to go away. We know how to solve one variable equations. We do not have a way to solve a two variable equation down to an x equals or a y equals without it having other variables in it. So here we go. This is going to plug in for the x, so it's going to be the opposite of y plus 60 going in here, and then we have to write the rest of this equation, so it's going to be plus 3y equals 220. We're going to solve this equation. Guys, the solving part we've spent months working on, so this part should be something you should be able to do, but if you still have questions, you need to ask me. That's going to make this negative 5y plus 5 times 60 is going to put you at 300 plus 3y equals 220. We need to combine like terms. When we combine like terms, we would be combining this negative 5y with this positive 3y. They're on the same side of the equal sign and they are like terms, so that's going to give us negative 2y plus 300 equals 220. We're going to minus 300 to get our variable by itself. That makes it negative 2y equals negative 80. We're going to divide both sides by negative 2, which gives us y equals, now the negatives cancel out, and we get y equals 40. Guys, you can get negatives, it's okay. Positives or negatives, doesn't matter. This is a place on the graph, there are positive and negatives on your graph. Now, we have solved this for our y this time, so when we're setting up our answer, our ordered pair, remember, since this is the y, it's going to go in that second spot. It's going to be 40 right here. Every single time you get that first answer, your second step is to plug it back into the box. You've got to plug it back into the box. It'll make your life easy because it already says x equals. So it's going to be x equals the opposite of y is 40 plus 60. So guys, the opposite of 40 plus 60 would be positive 20, which would go in our x spot, and we now have our solution to this system of equations that is consistent but still independent of each other. Now guys, look at that answer, 2040. That would have been terrible to graph. That would have been huge. It would have taken up so much space. And if you number by something other than ones, then the intersection point is very hard to find. Okay. I think we've got one more that's a regular case, and then we've got the special cases to talk about. So let's do this last normal one. So when you look at this one, there is only one variable that has nothing in front of it. That's this y. That is absolutely going to be the one that you need to solve for. So I'm going to rewrite that equation, negative 2x plus y equals 3. And I'm going to solve it for y, or put it in slope-intercept form. That's what we're going to be doing. So I'm going to add 2x, add 2x. That's going to make it y equals, remember, you always put the variable term first, so it's going to be 2x. Since the 3 is positive, it's going to be plus 3. That gives us what y is equal to, so that gives us our box. Now, we solved the bottom equation, so we need to plug back into that top equation. I'm going to plug this into the y in the top equation, so it's going to go in here. It is going to replace or substitute in for that y, so you're no longer going to have a y. It's going to be 4x, because that's out in front, plus 3 times, and guys, whatever this is now what this is. So now you have in here a 2x plus 3 equals 14. Got to write the rest of the equation. Now we solve. You know how to solve an equation. First, you've got to get rid of these parentheses by distributing. It's going to make it 4x plus 6x plus 9 is going to equal 14. You're going to combine like terms. Your like terms are going to be right here at this 4x and this 6x. That's going to give you a total of 10x plus 9 is equal to 14. We've got to isolate that variable, so we minus 9 minus 9. It's going to give us 10x is equal to 5. We're going to divide both sides by 10. Now guys, you should be able to reduce this, but your calculator will always also do it. You know how to do that. 5 fraction button 10 equals, and if you divide the top by 5, that gives you 1. If you divide the bottom by 5, that gives you 2. So guys, x is going to be equal to 1/2. X is going to be equal to 1/2. So when we set up our ordered pair, again, we talked about fractions or decimal is the reason we do these. This method gives us exact answers, not estimates, when they don't fall at nice whole numbers. Okay, here we go. We're going to take our answer, and we always plug it back into the box. Guys, it's the same thing every time. If you do the same thing every time, it makes it easier to remember what to do. Plug it back in the box. That makes it y equals 2 times 1/2 plus 3. That means y equals, guys, you have a fraction calculator that will do this, but sometimes you need to think that there's a whole day on the EOC that does not have a fraction calculator. So if you can do it without using your calculator, it will benefit you. Half of 2 would be 1 plus 3, which means that y would equal 4. There is your solution to this system of equations, which would be consistent but independent of each other. Okay, so the only thing we have left then is to talk about special cases, because there are always those special cases in math. So the exception to the rule is going to be the ones that are not just intersecting at one point. So we've got this system of equations right here where it's already set up as x equals. We take and put a box around this x. We're going to plug in this to where the x is in this problem. So again, let's show you through highlighting. We're going to plug this into here. Why do I plug it in there? Because it's the x equals. I'm plugging it in for x. That x is going to go away, and it's now going to be 7 times in parentheses negative 2y plus 4 plus 14y equals 28. Again, that x goes away, and this goes in its spot. We solve that equation by multiplying across. That makes it negative 14y plus 28 plus 14y equals 28. Guys, bells should be going off, lights should be flashing in your head. You should be looking and noticing what's kind of unique in this case. When you have a positive and a negative 14y, they are going to cancel each other out. And when the variables go away, there are only two choices. Either the two numbers are equal to each other or they are not. In this case, they are equal to each other. Guys, if they are equal to each other, that means these two lines are exactly the same line. So it's going to be a graph, and then it's going to be another graph of the exact same line right on top of it. If we solve this one for x, it would equal this exact same thing. because of that, remember, every single point is in common, so we write infinitely. Oop, my line didn't connect. Many solutions. Infinitely many solutions. There are an infinite number of points that they share that are solutions in common. Now, the other special case would be that when you get done with this process, instead of getting two numbers that are equal to each other, you might get two numbers that are not equal to each other, like 28 does not equal 25. In that case, you would be looking at two lines that never touch each other, so they would run parallel to each other. And in that case, since they never touch, the answer would be that there are no solutions in common. We write no solution. There is no solution that will make the two sides of that equation, or those equations, equal to each other. There is no intersection between those two lines. Okay guys, those are your special cases. You should have enough examples now to go through and work through your homework. Let me know if you have any questions on your mind, and I will see you tomorrow.